This is the first of three major applications of using tangent lines in calculus. This is by far the most important one. Notice that this semester we've estimated slopes of tangent lines and we've estimated areas under graphs. We haven't actually estimated function values. In this section, you start using tangent lines to do that. It is important to note that every function value calculated by a computer starts the estimation process exactly this way, and you want to get used to it if you're going to take Calc 2, because about a third of Calc 2 builds on this and expects you to really understand the process. If you're not going on to Calc 2, people in your field usually expect you to be ninjas at this. So either way, we have to be really, really good at it. The example I want to run through in this video is to estimate the cube root of 9. The main idea is, instead of plugging into a function that we can't really evaluate, we're going to plug the number into a nearby tangent line instead. Now, I'm going to get the directions about what we're going to follow. It's not hard, but there's a lot of little things to get right. I am going to go over to Desmos because it's going to draw the pictures so much better than we are. So meanwhile, I'm going over to Desmos. And here's what it is. You can see that I've gotten our estimate cube root of 9 here, and I want to start writing something down. Now, the very first thing is, because we're going to use tangent lines, right, we have to have a function, right? Okay, so what function do I see? Well, I see cube root of x. So what I'm going to do is walk over here, and I'm going to write f of x equals x to the 1/3. Now, I'm going to write it that way so I can take the derivative. Now, once I do that, I'm going to go back and look at the process. Okay, here we go. Now, the idea was plugging 9 into cube root sucks. So what we want to do, well, first off, let's say x equals 9. We'll just leave it at that. Probably not a good idea, but we'll see. And the idea is we want to plug 9 into cube root, but it sucks. So what we want to do is plug 9 into a nearby tangent line. Well, what do we mean by nearby? What we want to do is find a number that's close to 9 that's easy to plug in. Let's actually just write that in the note. Yes, we need to find a number. Find a number. We're going to call it A, so that A is close to 9. It's got to be a nearby tangent line and easy to plug in. In this case, I think the obvious choice is 8. Let's choose, how about a space there? That'd be nice. Let's choose A equals 8. A equals 8. So what I want to do, I think what I'm going to do is, because I want A equals 8, I'm just going to move this over here so I have a lot more graph to look at. The idea is we want the tangent line at A equals 8. So what I'm going to write down is our formula for tangent line again. Let's make that a little note so it doesn't get in my way. What do I want here? I want note. And how about L of x equals f of a plus f prime of a times x minus a. So we already said, well, how about if I write down a equals 8? Maybe you'll get mad at me, I'm not sure. What I want is f of 8 in this case, and that's just 2, that's good. I do need the derivative, so I'm going to take the derivative, f prime of x equals 1/3 times x to the minus 2/3, like that. That's good. I don't want it graphed, and I think I can shut it off if I want. Let's do that. Yes, I do, however, want to plug in 8. So let's give myself a little bit of thing here. I want f prime of 8. I think, yep. For what it's worth, that's exactly 1/12. When we write our conclusion, we'll write 1/12. I now want the tangent line itself, and I'm going to call that L of x. So I'm going to write down L of x, and hope it doesn't get mad at me, is equal to f of a, which was 2, plus the derivative at a, which is 1/12, get out of the fraction, times x minus 8. Now, you can see this tangent line is just veering off this way. I'm going to zoom in a little bit and then zoom out a little bit just so you can see what's going on. Right? Now, you can see when we're near x equals 8, for a big long stretch, at least 7 to 9, maybe either more like 6.5 to 9.5, you can't tell the difference between the line and the curve, right? It's only way over here or way over here that it gets to be a problem. And what does that mean? That means if we plug, for example, 9 into the tangent line, we're going to get an answer that's almost exactly equal to the answer we get when we plug 9 into the function, which is what we want to do. Let's see here. What do I want to do? How about I'm going to write these things as a conclusion. I have these on a picture somewhere. Let's see. Can I zoom out and get my thing back? Yeah, there it is. Good. Now, what I want to do is just put the next conclusion. And there's one conclusion, right? Here's our linearization. Here's our formula for our linearization. And here's the actual value of the tangent line. And we're going to need that every time. And now I want to draw a conclusion. And I would like to see this conclusion every time we do this. And this is what it says. The cube root of 9 is what we're after. Well, that's what you would get if you plug 9 into the function. That's too hard. That's almost identical. You can see up here. It's what you get when you plug 9 into the line. Now, when you plug 9 into the tangent line, you get 2 plus 1/12 times 9 minus 8 equals 2 plus 1/12 equals 2.08232323. I would like to do a check. So let me close this folder so I have a little bit of room to do a check. How can I possibly check? Well, the definition of the cube root of 9 is the number that you cube to get 9. So what I'm going to do as a check is I'm going to take 2 plus 1/12. That's supposed to be very close to the cube root of 9, and this is how I'm going to check. I'm going to cube it. And that's what we get, 9.04222222. It's not that close. I was hoping it would be a little bit closer. But all we had to do was find a line and plug into a line. We didn't have to do any fancy stuff with the cube root, nothing. But that's the basic process. Just running through this again. Someone's going to ask us to estimate a function value. We have to have a function. We have to know what number we're going to plug in. We need to find a number that's close to, in this case, 9, that's easy to plug in, and we'll call that number A every time. We have to remember the formula for the equation of the tangent line. Then we need the function, we need the derivative, we need to plug in the nice number both times, and then we have to write down the equation of the tangent line, and that's the last thing we did here. And the very last thing we need to do is write down this big long conclusion, because it actually summarizes everything we've done and gives us the right kind of conclusion. When we can check, I would also like to see us check.